Today we are going to discuss about the topic linear homogeneous second order differential equations. The differential equations of the form a into d square y by dx square plus b into dy by dx plus c into y equal to q of x is called a second order linear differential equation. If q of x equal to 0, then the equations are said to be homogeneous, and if q of x not equal to 0, then such equations are known as non-homogeneous second order differential equations. Then we consider the homogeneous type of differential equations. That is, the general form of such equations will be a into y double dash plus b into y dash plus cy equal to 0. In such equations, we can solve such equations by substituting y equal to e raised to mx in the given equation. Then we have to find the value of m such that the substitution will be a solution of the differential equation. So, if we are getting y equal to e raised to mx, the first derivative y dash will be e raised to mx into m. And the second derivative y double dash equal to e raised to mx into m square. So substituting the values of y, y dash and y double dash in the equation, we get a m square e raised to mx plus b m e raised to mx plus c into e raised to mx equal to 0, such that the equation becomes a m square plus bm plus c equal to 0, since e raised to mx is not equal to 0 for any x. Okay, so the equation a m square plus bm plus c equal to 0 is known as the characteristic equation or auxiliary equation of the differential equation. We solve the differential equation based on the root of the characteristic equation. Since the equation is of degree 2, it is a quadratic equation, we get two values for this m. Let it be m1 and m2. And depending on the roots, we have three cases. The first case is when the roots m1 and m2 are real and distinct. So, we get the basis of the solutions as e raised to m1x and e raised to m2x. And the solution will be c1 e raised to m1x plus c2 e raised to m2x. Then second case is if we have the repeated root, that is the values of m1 and m2 are same, which we represent it by m. So the basis of the solution is e raised to mx and x e raised to mx. So the general solution will be of the form c1 e raised to mx plus c2 x e raised to mx. Then the third case is the roots of the auxiliary equation is complex roots. Let m1 equal to p plus iq, then m2 will be the conjugate p minus iq. So the basis of the solution becomes e raised to p plus iq into x and e raised to p minus iq into x. The general solution will be e raised to px, e raised to the real part p into x into c1 cos qx plus c2 sin qx, where q is the imaginary part. So based on these three cases, we find the solution of a homogeneous second order differential equation. Then we can write it as, if the two distinct real roots, if we have the discriminant is greater than 0, so we let the solutions be e raised to m1x and e raised to m2x. So the solution y of x will be of the form c1 e raised to m1x plus c2 e raised to m2x. Then case 2 is equal roots if a square minus 4b equal to 0. So the solution will be y of x equal to c1 plus c2x into e raised to mx. Case 3 is distinct complex roots, which we write in the form p plus or minus iq. So the solution y of x equal to e raised to px into c1 cos qx plus c2 sin qx. Now we look into some examples. First we consider the example for case 1, that is real and distinct roots. So consider the differential equation y double dash minus y dash minus 6y equal to 0. So we can substitute e raised to mx equal to y. So y dash and y double dash. So our auxiliary equation becomes, after substituting the values, m square minus m minus 6 equal to 0. So we can factorize this equation as m plus 2 into m minus 3 equal to 0. So we get two values of m. Let it be m1 and m2, and the values are minus 2 and 3. They are distinct and real values. So according to case 1, we write the solution as y of x equal to c1 e raised to minus 2x, the first root m1 value minus 2 plus c2 e raised to 3x. Okay. Then an example of case 2. Consider the differential equation y double dash minus 6y dash plus 9y equal to 0. So the characteristic equation will be m square minus 6m plus 9 equal to 0, which is m minus 3 whole square, which is the expansion of m minus 3 whole square equal to 0. So m equal to 3 and 3, repeated root m equal to 3. So according to case 2, the solution y of x will be equal to c1 plus c2x into e raised to 3x. Now we look into an example for case 3. The differential equation is y double dash plus 2y dash plus 6y equal to 0. Then the characteristic equation is m square plus 2m plus 6 equal to 0. Solving the characteristic equation, we get the roots m1 as minus 1 plus or minus root 5i, and m2 is minus 1 minus root 5i, which are complex roots. Therefore, according to case 3, the general solution will be y of x equal to e raised to minus x. The real part is minus 1. So e raised to minus x into c1 cos root 5x plus c2 sin root 5x. Root 5 is the imaginary part of the root. So if the roots are imaginary, the solution will be of this form. Thank you.